Welcome everyone to this video. This video will cover 2D force vectors. Up to this point, we've been talking about forces in one direction, whether it be, on one axis, whether it be the X or the Y axis. So we really haven't talked about forces being at an angle, and that's really what we're going to tackle today. And I'm going to show you how to discuss those problems, how to find the actual values and what we call components. So just a quick overview and review of what we've covered so far. Forces are vectors, meaning that this quantity has both magnitude and direction, and that's what makes it a vector. So as far as magnitude, that's just the value of the force, whether it be 10 newtons, 100 newtons, 500 newtons, whatever that number is. That's just the magnitude. Now that number doesn't give you the direction. The direction has to be determined by you. So we're going to use a convention that up and to the right is positive, and that left is and down are in the negative direction. So in a free body diagram, the free body diagram will not show the positive or negative sign in front of the magnitude. Okay, all it's going to show a dot with the direction of the vector, whether it be up or down. It's not going to give you that this is positive n and it's going to be negative n. That is not going to happen. Okay, that has to be determined by you. And why don't they give you that number? Well, they don't give you that number because you have the liberty of choosing whether the right is positive or the right is negative. You can do that by flipping the axis. Okay, but I suggest that you don't do that. I suggest we stick to that right is positive, and that up is positive, and that left is negative, and down is negative to create some consistency. However, not all forces are linear, such as that they're not in one axis. They may be what we call two-dimensional vectors or two-dimensional forces. If a force is two-dimensional, it can be broken up into what we call components. And components is just a fancy word for sides to a right triangle. Okay, so let me give you an example here. When we do a two-dimensional vector, let's say we're going to have a flat surface here, and we say that this force vector is force vector A. Okay, so force vector A currently is at an angle theta from the positive x direction. So this force vector A has two components. Okay, and why can it be broken up into component? Well, this can be done because this is a 2D force and it is contributing to both axes. So let me draw what these two components are. So one of the components is in the right direction. Okay, that's the component that is contributing to the x-axis. The other component is in the y direction. That's the one that's contributing to the y-axis. So it's doing two things at the same time. This y component, we're going to call it f sub a in the y direction, and it's a force vector just like this one. Sorry about that. And this is force vector a, the x component of it. So how in the world do we find how do we actually calculate what those components are equal to? So for this, we're going to have to use a little bit of trigonometry. So just a few reminders. We're going to use sine theta. Sine theta is equal to opposite over hypotenuse. And that's where you get the so. Cosine of theta is equal to adjacent over the hypotenuse side. And tangent of theta is equal to opposite over the adjacent side. Okay, so whenever you have the hypotenuse, that means that you're either going to use cosine or sine. Okay, if you're missing the hypotenuse, that means you're probably going to use tangent. So how do I know that I'm going to use sine and cosine? Where sine and cosine have hypotenuse as part of their equation. Okay, that's how I know that I'm going to use sine or cosine. So in this case, to find let's say f sub ax, so f a x, that's going to equal to, you always do this, you always multiply the hypotenuse. In this case, that's just f of a, or sorry, f a, and we're going to multiply it by, since this is the adjacent side, this is adjacent to the angle, we're going to use cosine because that's the one that includes adjacent. Okay, so we're going to multiply it by cosine of whatever theta is. Obviously, we don't have a number yet, but we will whenever we have a problem. So then to find the vertical component, we just do f sub a y, and again, we multiply the hypotenuse. You always start off with that, okay, with the hypotenuse. Multiply by the hypotenuse times, in this case, we do sine of the angle. Sine because it is the opposite, and if you were to think about it, I can get this vector here and draw it right there. It's the exact same value. Okay, why? Because this is a square or a rectangle. Okay, so that's of equal magnitude. So this side is the opposite side of that angle. Okay, so this is how you've tackled 2D force vectors. So let's do some quick examples with some actual numbers and an angle. So I'm just going to pull random examples. And let's start off with, let's do some type of surface here. So let's say this force vector is 10 newtons. And to kind of practice, I want you to do this on your own. Well, let me do one with you, and then you can do this on your own. All right. So, and this angle, I'll give it to you. Let's say that is 30 degrees, a nice little angle. And on the AP exam, you're going to see nice angles like this, 30, 60, 45, and 90, maybe even 180, 120. So it'll be nice angles, things that you know, and that's based off the unit circle. So those are numbers that you'll remember. So anyway, so let's find the horizontal component here. So I know that this horizontal component is going to be 10, the hypotenuse, times cosine of the angle, and in this case, it's cosine of 30 degrees. The vertical component is going to be 10 sine of 30 degrees. Right? So sine of 30 is 0.5. So I know that this value over here is going to be 5 newtons. Okay, you can verify that in a calculator. I think cosine of 30 degrees is this is square root of 3 over 2. So this is going to be 10 times square root of 3 over 2. And in other words, this is just 5 square root of 3, whatever that number is in newtons. Okay, so that's how you find the sides to a triangle. Therefore, let's do some example where we have a free body diagram. Okay, so this is going to be a free body diagram example. So let's say we have weight in this direction, normal force in that direction, and I have a force to the right. It should be flat, I'm sorry. Flat, and we call that force to the right. And then we have a small force in that direction, and we're going to call this, let's say, for example, tension. This is just a random example. So let's say I give you that this angle here is 30 degrees. Okay, so we can throw some numbers in there if you like. So let's go ahead and do that. So let's say the weight is 100 newtons. Got a force to the right. Let's say that's 30 newtons. And let's say tension is, I don't know, 10 newtons. Okay, the question is probably going to be find the net force, first of all. And it also will ask you find the normal force. So in this case, normal force and weight are not going to be equal. The reason why is because this is taking some away from the normal force. Okay, so let's take care of this in by axis. Okay, so let's focus on the x-axis for now. On the x-axis, we have, let's start off with F net. You always start off there. Forces to in the positive direction plus forces in the negative direction. Okay. And obviously, it's a sum of. Okay, so the net force here, obviously, it turns out to be m times a. Okay, but don't worry about that right now. We're just going to worry about the net force. We'll do the calculations for acceleration later. So in this case, the net force, we take the forces to the right, and if we're looking at the x-axis, the forces to the right, the forces in the positive direction, we're taking right as the positive direction, and we're looking at the x-axis. For that reason, the only force to the right in the positive direction on the x-axis is the force to the right. So I'm going to write 30 newtons. Then I'm going to add those forces in the negative direction. But if you notice, tension is not in the negative direction. It is at an angle, and the angle is here. But a part of tension is in the negative direction. Okay, so that part right there is tension in the negative direction. So in other words, that is just 10. It's adjacent to the angle. So I'm going to do 10 cosine of 30 degrees. Okay. So you go ahead and do the calculations here. That'll be 30 plus, what did we do over here? 5 square root of 3. Okay. Remember that this value is negative because it's in the negative direction. So whenever you do the subtraction, that will give you the net force on the x-axis or in the x direction. Now let's focus on the y-axis, and you can go ahead and take care of that number using a calculator. So let's go ahead and look at the y-axis. In the y-axis, we have 3 forces. Okay, so let's start off with F net F net equals to the forces in the positive direction. I'm going to start getting rid of the sigma sign for now, just so I can go through this quickly. So the net force is equal to force in the positive direction. In the positive direction, up is positive. We have two forces that are pointing up. We have a part of tension that's pointing up and the normal force. Okay, so the net force here is equal to normal force plus, and I'll put these in parentheses because these are the sum of the forces in the positive direction. Normal force times tension sine of theta plus the forces in the negative direction. I only have weight. Okay, so if we want to find the net force, we need to know what normal force is. And generally, the net force on the y-axis will be 0, only because the object is probably traveling on the surface. So there'll probably be a word problem that goes attached to this. So in this case, let's assume that the net force is 0, and that was told to us, that was given to us in the problem. So I'll make a little division here. So the net force will be 0. That means that normal plus tension plus weight, normal plus tension sine of theta plus weight will equal to 0. So if I want to find a normal force is just equal negative t sine theta minus weight. I move that over. I'll just subtract that and subtract this over. Okay, so I'm skipping a few steps just for the sake of the video. So normal force can be found by using this. Okay, so t is 10. So I do negative 10 sine of 30. This is just going to give me negative 5. And I subtract negative 100. So negative 100 newtons. Okay, so negative 100 newtons. So you're adding 100. That means that your normal force is equal to 95 newtons. Okay, and since the net force on the y-axis, I forgot to put a subscript here, that the net force on the y-axis is 0, the only net force you have is the net force on the x-axis, which you are going to find. So you got your two answers here, the net force and the normal force of 95 newtons. So we'll do a few more practice problems in class, but just start getting familiar with the whole idea behind two-dimensional forces. All right. So I hope this was a quick lecture. Again, we're going to do some practice problems in class, so stay tuned for that. Thank you.